Today we will be starting with one of the very important library, and this library is called as the NumPy. It's actually a short form for numerical Python. So if you want to check what is this NumPy basically is doing and what is its significance, let's check this. So it's actually a library, and the fundamental idea behind uh, the library is that specifically they want to create arrays and want to operate with arrays. So one question that might come now is that in the basic Python itself, we can actually create the lists, right? And lists are in some sort, it's already an array. So why don't we use the lists for this purpose? Uh, right? Is there any advantage compared to the lists using NumPy to create the arrays? So if, right, as we can see here, our very fundamental idea here being the usage of what is called as the working with arrays. So working with arrays itself is very important because uh, the lists can store any type of data. Okay, in the sense you can put strings over there, characters over there, and you can put numbers, you can put floating values, integers, floating values, etc. Many things are possible over there, and that actually will look like a problem, will actually look like a problem for us, right? What's the problem and how to overcome that, we will be discussing that, and how the NumPy overcomes that also we'll be discussing. So basically the application of this NumPy is in the field of linear algebra, Fourier applications, matrix algebra, etc. So at very first, the idea of requirement of creation of such arrays, uh, again, the feature of NumPy arrays is that it is very fast. How fast? I'll demonstrate at the beginning itself. That idea came initially for Travis Oliphant, and he created this NumPy in 2005. And later on, it was developed. It's free to it's a free source. Everybody can use it, and it's available for free of cost. It's actually nowadays it is a part of Python. As soon as we install Python, NumPy comes with that. So that's one of the feature. Now when, as I already mentioned, if I use the normal that's a list for creation of arrays, that actually is very slow. Now how this NumPy overcomes that, we'll be discussing the same thing now. So if at all our intention is to do a faster calculations, right? Uh, NumPy aims to allocate the computer memories, right? The memory in a computer in a linear fashion, in a sense, one after the other. The elements which are stored in the array, NumPy array, gets continuous addresses, whereas the list can store it separately. So what do you mean by separately, right? I'll show you another one. Okay, I'll try to show you another diagram over here. So basically, if I try to use a list versus, if I try to compare a list versus NumPy array, this is the best suitable example I can show you. Just see here. So this is what happens. In case of NumPy, continuous address locations are allocated for the numbers or the whatever we store in the NumPy array. This is just because all everything that you store here will be of the same type. That's why you can fix that. Okay, my first element is a number, integer. Second one is also integer, integer, integer. I know that how much space is required. So if I have 8 different integers, I can initially calculate, okay, these many this much space is necessary for my array, and I can allocate and I can store the numbers. But you see, in case of the Python list, we have a problem. The problem is that maybe the first number is an integer, so you store it here. Integer gets maybe one or two places. Next number is also an integer, you will store using two places. But you see that maybe its next number requires more space, so you store it at a different location. You see here, maybe there is someone with some entry in the list, Python list, which takes more memory. So more memory means I need to allocate more space, right? So that's the problem. So because of which, right, while reading the element by element, it says the address, you see the addresses are stored in completely random fashion. This is according to the availability on the computer, right? In the computer memory, wherever you have sufficient amount of memory, you are trying to read that, right? So that is what is a very simple difference. This is very minute difference, but this minute difference itself makes lists to be operated at a very slow speed. Lists can be accessed very slow, but if you are using what you call as let's say the numpy for the same purpose, it's going to run very fast. All right, I'm going to show you one more example, right? So this actually makes things very clear. So let me try to create a NumPy array first. I'm going to call it as my, okay, sorry, I need to import, right? So let us look at the import part first. Import, you will call NumPy as NUMPy. So as always, you know that you give an alias name every time. You don't have to write NumPy. So it's NumPy as the most common alias is NP. So that means it's the NumPy array. All right. So actually, I'm bringing the NumPy into the computer memory, and what we do, we can actually check the NumPy. So that is NP dot underscore underscore version underscore underscore. So this actually tells you which particular version you are using in your computer. So same thing holds good even on the what you call as the collab, right? Even if you checked in collab, I will not open the collab separately to show you this, but anyway, I'll paste one snapshot which I have taken recently while running the same thing on the collab. You can see that, right? So import numpy underscore underscore version underscore. It shows this. All right. So that's how we get this. And as usual, you can get the help in the same way, right? Like earlier we have checked. So you can go to the np dot question mark. Sorry, np dot and tab. So when you enter a tab, right, you will see that you are going to get the complete list of functions available under this particular module or library that is called as numpy. So I'll just give a comment over here just to make sure that when you look at this at a later stage, you will understand what exactly is happening. So this is np dot. I'll write a tab, right, to get the right list of to get the display of contents inside this np, right? So I can use that. Then the next part is to look at the np documentation. So if you want to look at the NP NumPy documentation, the suggested way is NP, that's NumPy, and you write a question mark. So you can see that as soon as you run, you will get a documentation opening. Right. So this gives a very brief introduction, right, to the NumPy. You can use it, right, just to check the basics of this. Okay, but let's say we want details. We want more details about NumPy. Right. So there is the NumPy documentation available, and we can directly check that over there. So that's the second method. But now directly I'll move to the one topic which I was discussing earlier. That is, how fast is this NumPy? Okay. So just to justify that part, uh, I will show you one part of the code. So let me create a NumPy array. Don't worry about the creation part. I'll come to the basics again, starting from how to create an array, etc. So now let me directly show you something. This is I'll call it as my array. I'll create this using NumPy. So the NumPy method is np dot arrang. It's like it's a range, but it says a range, saying that it is array. All right. So I'll enter a larger number, say 1, 2, 3, 4, 5, 6, 7, 8. So it's a larger number. I create an array of this size, and also I create a list. So this is from the basics of Python. We already have studied. It's a list of range. Give the same number, same size. Okay. 1, 2, 3, 4. Let's see. So I create this. It gets created immediately. Now let us try to let's try to operate on this. So to check the time of execution of a line of code, we use what is called as time it in Python. So percentage time it will calculate and display the time of execution of a command that actually comes in the same line of this command. Wherever you write percentage time it, and followed by that whatever you write, right? So that particular command execution takes how much time, right? Will that will be counted and displayed by this particular function. Okay, so let me start with this. Say for when you don't have any variable, you can even use underscore for nothing, right? In the range 10, that nothing varies from 1, 2, 3, 4 up to 10, right? 0 to 9. So in range, I want this to execute, say 10 times. Maybe 10 itself is more than sufficient. My array 2 equal to my array that's already created in the previous line. I'll try to raise each and every right, each and every number. Okay, let me multiply that. I don't even have to do the what you call as raise it to the power. Let me say every number I'm doubling in the array that is created using number. Okay. So let's see the time it's going to take. So you can see that this is a huge number. The array is very large. So again, the time taken to run a code depends upon the computer hardware architecture on which the code is being run. So right now it depends upon my computer's architecture. All right. So maybe you find slight variations in this number when you run on your system or when you run on Collab. Okay. Now what I do, I want to do the same thing, but a same operation on a list. Right. So this is percentage. Again, I need to calculate the time. So I have to write the time 8 followed by once again for in the range of the same number, say 10. What I want to do, right? I will try to create an array. So that is my list 2 is equal to every element in this needs to be multiplied by 2. So this is x into 2 for every x in this list, my list. So you see the answer is going to be a list. So let's just check how much time it's going to take, right? So we can see that it's actually taking more time. I think we executed the line number 6 within this time, but now I can see that it's taking much more time. So how much more time it might take? Again, basically depends upon the computer architecture itself, but as we can see, it's too much more time compared to this. So you see, this is in milliseconds, this is in seconds. So right, if you divide this 6.27 divided by 126 milli, you can see that how faster is the numpy. So that gives us a answer saying that why this numpy is faster. So the answer I already mentioned that the NumPy arrays are stored in continuous space of memory, unlike lists. So accessing, processing, etc., becomes very fast, right? If this does not happen in the contiguous memory locations like lists, accessing and processing becomes pretty much difficult. Okay, so one more reason is that most of the NumPy is written in C C++. They are much more hardware friendly languages compared to the Python. So where the list operations are pretty much written in what you call as the Python. So again, that's one more reason. So even nowadays, if you are trying to develop any application which is embedded, which includes a lot of hardware, and right, the interaction between hardware is more, then people now also prefer C++ only, because much more hardware friendly nature of those languages compared to other language. Okay, so that is that's what we uh, have to know before we start. Right, now let us start with the creation of an array. Right, so the first part is to create a NumPy array, and this itself is what we call as the NumPy as a n-dimensional array. Always we can specify the NumPy array as a n-dimensional array. That's another advantage over here. If you see the basics of Python where we use lists, we were not able to create uh, n-dimensional arrays like 2D means matrix, 3D, 4D or 5D, etc. This was not possible. Okay, but yes, if you want to go for image processing, your dimensionality increases. Whatever you handle is a two-dimensional thing. If it is a color image, it is a three-dimensional array. So we have to, there is a absolute requirement that you need to use what is called as n-dimensional array. Okay, so any simple array, even if you create a one-dimensional array, the NumPy says that it is a ND array with dimension equal to 1. Okay, so how do you create that? Let's see. So I'll say my array 1 is equal to, this is the method, np has to be used because I have created a alias called np. But if you're not creating an alias, every time you have to write here numpy. Okay, numpy dot the function, as you can see here, right, it's array. Np dot array is a function. Now you need to enter what you want to write. So what should be present inside this array? So this is 1, 2, 3, 4, 5. Let's see. Okay, so I create this array. So if I write print this, print my array 1, you see it prints, right? Pretty much we can see that we cannot distinguish whether this is a list or not, right? But what we can do here is we can also try to print the type of, so type is, once again you can use the same built-in function called type to check the type of any variable that you have created. All right, my array 1. So it says it's a NumPy n-dimensional array. So this my array 1 is of that type. All right. So now you can actually, you see that this, though I have what I have passed here. So to create a n-dimensional array, right, I have passed a list to this. This is a list. As I can see that if I use anything inside the square bracket, the Python takes this as a list. Okay. Now you can see that to create this kind of n-dimensional array, right, we can pass a list, tuple, or any array like object to this, right? So let me write pass a tuple as well to create the ND array. So that means what I have to do, my array 2 is equal to, it's once again np dot array. This itself is a function, but what I do, I will not pass the list now. So you can see here the this place we are passing a list, but now I am not passing a list. I am passing let's say I'm passing a tuple. So right, so I'll pass this and I'll inspect my array 2. All right, so it says sorry, it's yeah, let me check this. uh, since you see the difference here, I am inspecting, but if I try to print, it actually displays properly. Print my array 2. So there is a difference. This is inspection, right? Line number 12, what you see here is inspection. Line number 13 is actually print. So there is a difference. So if you inspect, it says it is an array, right? If you print, it prints like normal list. But if you go to the print, you may have to check like the type of how we checked in line number 10, right? Like that, we need to check as well. Right. Now, so we can actually try to create a dimensions, various dimensions, array of various dimensions we can actually create. Right. Now, if you simply enter a value, right, that is actually called as zero dimensional array. Let me try to type that. So scalars, if you enter scalars to create arrays over here, then we'll be calling them as the zero dimensional arrays, right? So simple scalar. So let me try to do that. If I say my array 3 equals to np dot array, pass a scalar, just one number, say 55. All right, and you print this my array 3, you see that it's just prints as a number, right? So this itself is called as a zero dimensional array in NumPy. So scalars, zero dimension. Now, so let's go further. The most common types of what you call arrays that are created and used in this numerical Python are of this type. This is called as one dimensional array. Most basic thing. So let's try to create that. Already we have created right? Let me repeat that. Whatever we have created over there, that itself is an example. So my array 4 is equal to dot np dot array. You need to pass either list or tuple to do that. So all right, so this is a one dimensional thing. Print my array. It's a 1D case. Now let's go further, right? We can create a higher dimensional arrays as well. So as I already mentioned, right, if you are using something like the image processing, if you want to build an application for image processing, definitely I need a higher dimensional arrays compared one dimension. That means if it is a grayscale image, definitely we'll go for 2D arrays. Otherwise, you will have to go ahead with 3D arrays for representation colors. Right? So actually, higher dimension, more than one dimension, if it's 2D, 3D, 4D, etc., the Google terms it as a tensor, right? So it says second order tensor, 2D. 3D means third order tensor. The word tensor is actually coined for the same purpose. But the representation of those arrays in the Google servers are slightly different than how the numbers are stored in our computer. That's just because their own type of software computation, etc., will happen over there. That's why they term it as a different name, like tensor. So based on the tensors itself, they have developed a machine learning library called TensorFlow. Again, that's very famous. Even it is suggested to learn that because it is very powerful. It has a lot of features. So before that, let's try to create this, right? So to create a two-dimensional array, right? Let me write my array 5 is equal to, it's again np dot array itself is the function, but you see you need to specify the two dimensions. What do you do? This is making a list, but inside this list I need to enter two lists saying that okay, the first list is first dimension, right? The second list is second dimension. So you use another bracket. Okay, one, two. This is the first dimension. Come, enter the second dimension, right? All right, so this is what is the this is how you enter. So now let us check my array 5. Yeah, so I'm inspecting that. So it shows array of. So you see that the two dimensions over there, right? One is horizontal, one is vertical, because the second list which I have entered inside this list, right, it goes to the second row. So it's like a matrix for you. Right, now very similar to this, we'll discuss about the two-dimensional arrays, the operations, etc., right, in a while. So before that, let's look at the other common array that we might use if we build an application. Okay, so that is called as a three-dimensional array. So let's create a 3D array, right? Very similar to the 2D array, right? You can actually repeat a 2D array once again to make it a 3-dimension, correct? So if you have two pages, first page you write a matrix, second page also you write another matrix of the same size, it means it's 3-dimensional. Okay, so that's what is an example, right? So okay, let me my array 6 is equal to, once again you are going to use np dot array itself, but now we have to think, right, carefully to understand the creation of 3D array. So you see that if I use like this is a 2D. I need two 2Ds. So I need one more bracket on the outskirts. So what I do here, so this is the first this thing, and I need to write two 2D arrays inside these two brackets, correct? So enter first 2D over here, like the ones which we have already written, 1 1 4 4. All right, then I need to write another here to make it a 2D. Okay, so that is okay. So this is the 1D. Now what I do, I have to enter another one just to make things clear. I'll go to the new line. This is allowed. Okay, you can after a comma you can go to the new line. No problem in Python. Right. So next I'm going to enter the other numbers. Like simply I'll just write 1, 2, 3, 4. The first four elements. The first row of second page followed by 6, 7, 8. So you see that. Now let's create this. So it actually shows that there is in the upcoming versions this particular facility will be removed, right? It's just a warning, okay? No need to worry about it. So creating a ND array using this technique, right? It may not be right. It may not be what you call uh, supported always. So that this is what they say. Okay, so I have, yeah, I think I need to use another bracket, then that warning might go away. All right, so let me check this. Okay, so this is what they said, right? Without specifying another bracket, right? That facility is there now, but if you remove that, if you go to the next versions of upcoming versions of NumPy, that facility will be removed. Okay, that's fine. So let's try to print to visualize this in a very neat fashion. My array, this is 6, right? Okay, so you see that this is a 2 dimension. This is the second page of that, another 2 dimensions. So totally you have 3 dimensions. Okay, so this is how we create the dimensions of this. Now let us check to check the dimensions, right? So if what if I have not created a n-dimensional array, somebody else created this, but I want to check that. How do you check? So is it possible to check the number of dimensions of an array? Yes, it is possible. Even if we don't know, we can simply check it using NDIN. All right, so let me check that. My array 6 dot NDIN. It says 3. It's a 3D case, right? So just now we saw. So before that, I have created a 2D case, that is my array 5. I'll check that as well. So let me use a normally you if you are not inspecting, you will also write a print over there. So let me try with that. My array 5 dot enter. It says 2. Okay, now is it possible to go beyond this and create the arrays of higher dimensions? Answer is yes, right? So let's look at the let's look at what is called as the higher dimensional arrays, how to create them, right? Is it possible to create it in a much easier fashion, right? So let's check that. So the answer is yes, we can go with the higher dimensional array, and you can create that using NDmin argument. Okay, number of dimensions you can actually specify. For example, right, let's create my array 7 is equal to, so create, I don't have any other option than using np dot array. But you see, it's not necessary that you have to enter the, let me say I want to create a 5-dimensional array. So 5 dimensions, it's entering the matrix may be very difficult, but what you do, you can put some numbers here, maybe like 22, 44, 80. Let's say these are my numbers, but only these numbers are what I know. All the other numbers I don't. So, but still you can create a higher dimensional array, ND min, right? You will say equal to whatever dimension you want. It's 5. Okay. Now you see that it is created. Let me try to print this. Print my array 7. It still says that, okay, you can see that there are many brackets used. Or if you, my array 7, if you inspect that, you will see it differently. Okay, I can see many braces over. Now I need to justify, right? So just check my array 7 dot, what's the command? Ndim, ndim. So it says it has 5. All right, so that's how you can see that a n-dimensional array has been created, right? Can be created using the NumPy, right? Now, so next concept is that we want to access the element. Now we know how to create the array, n-dimensional array, specifically with respect to the uh, NumPy. So the next what we want is the indexing, right? So let's say how to access the array elements, right? Again, we need to remember some of the concepts which are common in Python. So array indexing is very similar, that like how we did the indexing of tuple, or maybe the list, the string, etc. Okay, so you have to refer the element by using the index number, and numpy starts with 0, like first element is number 0, then second number has 1, and so on. So this is the same concept we have been using since the beginning in this, right, in this in Python. All right, so let me create my array. Right, is equal to np dot. All right, so let me create this, and now you see I will try to access this, that is my array 8 of 0. So that is the first number. Okay, so I can also other than inspecting, you can print my array 8 2 is 33. Okay, fine. So accessing can be done in this fashion very easily in this. Now, so I need a very similar approach. I need to use a very similar approach to access the higher dimensional arrays. So if you want to access the various elements from a high dimensional array, right? What is the idea? Let's see. I need to mention which row, which column, if you are using a 2D case. All right. So let's check with that. So you see, I want to access the 2D array now. So if you want to access the elements from a two-dimensional case, I have to say that which row, which column. Okay. So row numbers start from 0, column numbers are also going to start from 0 itself. So we remember that, right? The indexing starts from 0. So for a one-dimensional case, even if it is a two-dimensional case, the second dimension being, right, first dimension being rows, second dimension being columns, you will always start from 0. So let's take up an example. Okay, so I'll create another a two-dimensional array first. So let's call it as my array 9. So that is equal to np dot array. So you remember I need to pass two dimensions, so I need to use two square brackets over here. So this is the first dimension, put a comma and enter the second dimension. All right, so that is all right. So we have we have created a two-dimensional array. I want to access, let us say, the second element in the first row, right? So first row means it has to be specified. Okay, let me type the name of the array first. My array, my array 9, my array 9, and I just have to specify the here always you write the row number, and second whatever you write is the column number which you want to access. So okay, let me write a point here before I run this. So this is 2, sorry. So let me write here, that is 2 access element from first row, second column. So row number is first. I know that first row has an index 0. Okay. Second column, 1 less than that, it's 1. Always I know I need to remember this. First row, second column element. Let me just oh sorry. This is capital, right? Sorry, my mistake. You see 22 comes in the picture, right? So in the first row, this is the first row, the second element. I can actually I can print this to visualize that in pretty much neat fashion. Right? My array number 9. You see that the first row second element is 22, which has been already printed. Right? So let's do one more quick exercise over here. Right? I want to read the say fourth element in second row. So what should I type? I just have to check my array 9 of, so fourth element in the second row. So fourth element in the sense it's a uh, fourth column, second row. So row number 2 means 1. Fourth element is 3. So fourth element in the second row is what? It's 88. Right? So let's check whether we get that. Yes. Fine. So that's how we access the what you call as the 2D arrays which we have created. And if you want to access any element from that, this is the method. Let's go further. So we know how to create a three-dimensional array. So it's absolutely necessary now to understand how to access the various elements from a 3D case, a 3D array which we have created using NumPy. So now the method that we are going to mention will be pretty much same. It remains same. So we just have to enter the comma separated integers representing the dimensions and the index of that element. So let me show you that. All right. So let me create a 3D case again. Right. So my array number 10 is equal to, it's np dot array. This is a function. Let's create a 2D case, right? So this is a 2-dimension. This has to be a 2D case. Again, I need to use another 2D case here, right? So inside the first 2D case, this is 1, 2, comma 6. I need to enter another 2D here. So this is one till 6 I have entered. 8, 9, 10, 11, 12. All right, let me give a thing here. So it creates an array, and let me print this once. So we can see the third dimension as well. So this is first 2 dimension. This is the second 2 dimension. So the second 2 dimension actually becomes your 3D case. Okay, now let me try to print this. So we have 3 dimension. So the dimension number needs to be specified first. It says that just read the statement given here. If you want to access a 3D element, you need to enter the comma separated integers. Right? Then first you need to enter which dimension you want to access. In the sense, this will be the third dimension number comes first. So this is the 0th third dimension. This is the first third dimension. Okay, then inside a particular dimension, if you want to access a number, say 6, after mentioning it as 0, then you normally write, okay, what you want to write, which particular uh, number you want to access, like how we did it 2 dimensional case, you can follow. For example, now I want to access this number 6, right? So if you want to do that, if you want to access that, this is what I would like to do. This is my array number 10. Now you see I have to enter it's like a page number. So which page? Each page has a matrix, right? Each page has a 2D array. So again, the number starts with 0. So this is the 0th page. This is the first page. So I want to access 6. The 6 is present in the 0th page. So first you mention that what is the page number. So that's like a dimension number. That's a 0. So that's what has been mentioned over here, representing the dimension first. So you talk about dimension, then the index. Index is for a given page. So the index of this number 6 is, how do I write this? It's present in the second row. So I'll write 1. This is the row number, followed by the column number. So it's present in the third column. So this has to be, so that is 6. So I will give a comment here saying that. So you will enter something like this, name of the array, followed by something like a page, followed by a row, followed by column. Fine. Now, okay, let's look at what else was there in list. We can actually try to implement the same thing in NumPy as well. Okay, let me go with the concept called as the negative indexing, because we have seen the negative indexing possible in case of simple lists as well as strings, etc. Correct? So let's look at that. So is it possible to use the negative indexing in case of NumPy? So if you ask that question, so the answer is always yes. So I create my array 11 is equal to np dot array np dot array, and I will just enter the two numbers 1, 3, 5, then create another one. So this is like 6, 7, 8, 9, and 10. Right, and let me try to access the last element in the second dimension. Okay, So last element in the second dimension, right, is actually last element in the second dimension. So dimension number 2 means it is the second row. In that, I'm trying to find out the element. So I can simply write like this. So I can use whichever dimension you want to find the last element, right? That dimension you put -1. That's all. Okay. So let me try to write that over here. If you want to check that, right? So it has to be my array number 11, first dimension, right? Since you want to go to the last, right? So it's a second dimension means second row. It has to be 1. Last number can be specified by using -1. So you will read 10 over there, right? So that's about the indexing. How do you access the what you call various uh, things in this NumPy? Okay, NumPy array. Now let's move ahead and let's look at what is called as the slicing. So can we slice these arrays like we did in the what you call the lists? If you ask that question, the answer is always yes, right? So let's check that. So as usual, right, we can go faster here because we have done this in yesterday's session. So you can enter something like start to end, but that was for list, right? Same thing holds good for the NumPy n-dimensional arrays as well. So you can either enter start end step. So if you don't pass a start, this is always considered as the first element, which is 0. If you don't, right, enter this sorry, the end, if you miss, it's always the last number. Okay, and if you don't enter a step, it's always considered as 1. So everything is pretty much similar to what we did earlier. Now let's take up some examples. All right, so I create np.array. So let's create a 1D case. All right, so I create an array like this. Now I'll try to check my array 12. So let me try to write this is 1 till 5, right? It means it is second element, third, fourth. So it's like second, starting from the second element. This is 0, 1, 2, 3, 4, right? So second to fifth will be printed. 6, 1 is excluded, right? So let's take up another example. My array 12. You see, I don't mention the first one, right? Starting point I won't mention. I'll just write it. So that means 0 till the fourth element, fifth one is excluded, right? I can write uh, my array 12 of, I'll say, fifth till end. Okay, starting from 5, so till the last. So 5 means it is the sixth element, 66 onwards it will print. In the same way, right, you can even use the step for this purpose. That is my array 12, start from 2, go till I think we have 8 in steps of 3. Let's see. So you see, this is how it prints out. At the same time, right, you can even try to use the negative, right? So I'll use the word the negative slicing. So if you want to do the negative slicing, I can write my array 12. Just write, use the negative words. This is starting from -3 till -1. So since this is the array, this is -1, 99. This is minus 2, this is minus 3, right? So minus 3 till minus 1, so minus 1 is not used. You will always print minus 3 and minus 2, that is 77 and 88. Okay, so again, right, just think of skipping every number, right, and printing that out. So that can be done using my array 12, and you write starting till the end with the step of 2. Okay, so very straightforward, right? That's all about the slicing of 1D case. Next I will discuss about the same concept, slicing 2D arrays. So first let's create my 13 is equal to np dot array. I need to create a 2D, right? So what I write here, 1 2 3 4 5. The second dimension is 6 7 8 9 and 10. Okay, and I print this 13 so that I can access, I can see what I want to check now. So let's see, right? Right, I just want to say slice the 7 8 and 9, right? So that's my question. I just want to slice 7 8 and 9. So you can see that 7 8 9 is this. So I use the same logic, right? It's something like, so okay, slice uh, slice, I can just write 7 comma 8 comma 9 from the 2D array. If you want to do that, so write the name of that, that's my array 13, and you see you just have to write which row it is, because as you can see the number 7 8 9 are present in the second row. Second row has index 1, and the 7 has to be sliced, 7 8 9 has to be sliced, but 9's next column number you need to enter here. So this is 1, okay, this is 1, this is 2, this is 3, but if you want to include 3 you have to write the next column number, that is 4. So this is start from 1 go till 4, right? Very simple idea. Let's recall. I just have to enter the row number and column number here. If I just write a number, it will pick up, it will slice a single entry. But if you want to, right, take out a complete row or a part of the row, it has to be, right, specifying which row and what are the positions of this, right? For example, I want to slice, let's take up an example, 3 and 8. If you see the 3 and 8, okay, let me write that 3 comma 8. So if you see 3 comma 8, it is actually the complete second third column, basically, right? The third column of that matrix. So how do I mention that, right? I will mention it like, so it's my array 13. You see, I want to read the two rows, row number 0 till I want to include row number 1, so I have to write 2, 0 to 2, and specify what is the index of that column, 0 1 2, right? So because it's a third row, it has to be 2. You have this option. There is an alternative method which, if you want to read every element in a row, right, you can say that all rows, because this 3 comma 8 means it is all the rows, correct? So I have to read every element from that row. So you can simply write like this: my array 13, all the rows, and the second column. This works pretty much fine. You don't have to write 0 to 2 because you are reading everything in that dimension. Every row you are reading. For example, if I want to read the complete first row, right? I want to read the complete first row. First row means row number is 0 and all the columns. My array 13, I want to read the row number 0, and you see, actually you need to write the number of columns starting from 0, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So 0 to 5 you need to write. Okay, but you don't have to write that. You just have to write a column indicating that all, everything you want to read. Okay, so now what if you want to read a part of this, something like I just want to read 2, 3, 4, 7, 8, 9. Let's say so, right? I just want to read 2, 3, 4. So slice 2, 3, 4, 7, 8, 9 from that from this. Okay, so let's try to write an answer for this. This is my array 13, and let me try to slice it now. So 2, 3, 4, it's actually right. 2, 3, 4, and 7, 8, 9 are actually, they contain both the rows, right? So I can write all rows, both the rows I want to read, but specific columns. What is this? What do you mean by specific column? I want to start from the first column and I want to go till first, second, third. So third is one I want to include. This 4 and 9 have to be included. This is row number 1, sorry, column number 1, column number 2, column number 3. Since I want to include column number 3, I need to write the next value as well. So that's why I write, so you see 2, 3, 4, 7, 8, 9. So that's the way how we can actually enter these. Right, now coming back to the various data types what are supported in Python. So let's quickly look at that and let's check that. So let's see that. So these are the data types supported, right? Supported in Python, right? We have used the strings, integers, float, boolean, complex, etc. We already have used them. Okay, but if we want to use the similar data types in NumPy, right? NumPy actually supports few more data types as well. Okay, so let me try to show them now. So you see the data types in supporting NumPy, right? So it's actually, right, we have the set of characters to represent what you are, which type of data, what is the data type that you are actually using here, right? In order to check that, in order to represent that, there is a specific what you call uh, character used. So you can see here I for integer, B for boolean, U for unsigned, F for. So that's a complete list what is supported here. Now let's try to check, right? If you want to, if you have already created an array, or if you are interested in checking the what is the data type of a n-dimensional array that already has been created, if that is our intention, so we'll be using this. Okay, there is a function, there is a property that's called as a D type. So this D type can be used simply to check what is the data type of a particular n-dimensional array. So let's check one of them now. So we have created up to 13. Let's go ahead. and create the array number 14. My array 14, that is equal to np dot array. You will, let's create 1 2 3 4, and what I try to do here is uh, the name of this array, that is my dot gty. It says data type is integer 32. Depends again on the version, 32-bit version, 64-bit version, etc. So it will be like that. So let me also try to create my array 15 is equal to np dot array. Now I will enter apple. All right, I create array using the strings. My array 15 data. It says u, so you know what is u. It actually stored in 16-bit unsigned format inside your computer. So it depends. Okay, so but I can understand that. So the though I write this, it's going to be changed in this. So it's capital U. Capital U is Unicode string. So always it is getting stored in the Unicode format. All right. But there is another facility here that you can actually create the arrays, n-dimensional arrays, by using a specific data type. Whatever data type you want to use, you can actually specify. All right. So let's try to. So creating the arrays with this specific data type, that's actually possible here. So now I just have to look at this. Okay, I just have to look at this list. I need to remember this because I will be specifying what data type I want by using a optional argument called the d type. So let me say I put the enter integers, right? I'll be entering integers only, but I want to save it in a specific format called string. Okay, so let's try to do that. So is equal to np dot array, give a list 1 comma 2 comma 3 comma 4 comma 5. I specify dty d type equal to, now you see I will specify say string, that is s. So it has to be under single quote and capital. Okay, now you check. Let's check this. My array, this is number 16 d type. So it says it is s. Then after that, whatever number is written, it's the number of bytes taken by this. Okay, so totally it's one, s1, right? Like that you can actually change. If you want integer of 4 bytes, you can do that. So let me copy this and paste. Let me try to create the same thing. I'll call this as 17, and I'll specify here. Let's go back to this. It's integer I, right? But I want to use 4 bytes for that. So if you want to do that, you can write I4, right? So 4 bytes is what? 4 into A, so 32 bits. That's why it is being shown. It's showing as 30. You can change, right? So that's how we can try to, right, do this. And if at all you want to convert, right, converting the existing arrays is also possible, right? Let's look at that now. So how to convert existing data types in an array to a different data type. That's also pretty much important because I might, whenever I want to implement a project, right, I collect the data from some sensors. Sensors are going to give a data in their own format, right? It may be maybe 64-bit representation, floating point, any format you think. But for processing, I feel that I need maybe integer format, right? Let's say if you want to do that, you need to convert, correct? So that's why this conversion is important. So any data that actually exists, right, already existing data format, you can actually convert. So there is a function, right, which is called as type. So if you use this, you can actually convert from any format to any other format. Existing format, you don't have to worry. You just have to say that I want f for float. I want I for integer. What is the format in which I want the answer, right? I just have to say that. Okay. Now let's check that. Okay. My array routine is equal to np dot array. Let me create array of a type, say float. Okay, that is 2.2, 3.3, 4.4, 5.5. Okay, I will check this, the data type, my array 18 dot type. It says it is floating 64. Now my array 19 is equal to my array 18 dot write as type. I want to convert. So as type, specify, you already know that list, right? Whichever type you want, you can write. So I have a float f present here. It's already float. I'll write I. Okay. And my array, this is 19 dot the type. Before that, I will print that as well. Maybe you lose some information because decimals, if you have decimal points and you convert to integer, maybe you lose it, right? So let's check that as well. My array, I print that as well as I check. So you see this, you got only 2, 3, 4, 5 because it's integer. So after decimal place, whatever you have, you lose it. So we should be okay for these kind of conversion. Other than that, yes, it is supported that you can actually convert using this technique. Right. Also, you see that the conversion to you can actually apply Boolean, right? Everything that we have seen in this particular list, right? It is possible. If you enter it as B, it will be converted into Boolean, right? You can any format that we think we can, right? We want to convert. It is possible over here. Okay, right. Then the next concept that we are going to discuss here is the copy and the view. We have two things possible in the NumPy. So they are, one is called as a copy and another one is called as a view, right? So if I try to say copy, I am actually trying to copy the content into the new location. So copy means copy owns the data. Any changes made to the copy will not affect the other array. In the sense, if I copy a content of one array to different array, so the different array, both will be, the results will be two different arrays. Change in one of the array will not affect the other. So that is what is a copy. But if you view, simply if you assign A equal to B, A and B both will be pointing to the same array. If you change A, B will also change. So that is, right? So that's a very basic thing here. So let's try to visualize that. My array 20 is equal to, this is np dot array 1 2 4. I create this. Now I'll say x is equal to my array 20 dot copy. I'm doing a copy now, right? After doing this, after a copy, I'll make change. My array 20 of 0. The first element I want to change is to 100. Okay, and now you see I will print array 20 and print x. So see, since you have done the copying here, right, it does not affect, right? And the second option, so this is actually, let me give a name here. So this is actually what I did here is the copy. Oh, sorry, it should be here. So we did the copy here, and now I'm trying to do the same thing here, but instead of copy, I'll view. Okay, so only the only change that we do here is this. So I'll change this to say new one, 21. This x is equal to 21 dot. You don't copy, you have to write view. This is 21 and 21 and x. Okay, let me change this to a new one because already there is, it will overwrite otherwise. So let me try to write it back. So you see here, both will remain same. Right. So normally what is the solution is, we can also do something like this, right? I'll try to copy this. I will write, this is 22, then this is 22 dot view. Let me say this is z, and what I do here, I will change in this, the z of 0 equal to 100, and I will print, this is 20, sorry, this is 22 and z. So let's check. Okay, let me change this to say 200, because otherwise we may, both will be 200 in the sense whether you change this z or the original array, it's one and same. All right, so that's how right, we will try to we just have to use them according to our requirement, right? So if you remember, the, the the things to understand here is that if I copy, that means both the copies own the data. Data is copied to both. But if you use view, you do not own data because both will be pointing to same. Any one of them you are changing, so it will actually, right, it will not own the data. So how is it possible to check, right, whether a array has data which is its own, or it is a copy, right? Is it own or not? You can check. Okay, so that's the next topic that we are going to discuss now. So how to check if an array has the data which is its own or not. So to check that, we have what is called as an attribute called base, right? So when you check the base, if it returns none, that means, right, it owns the data, right? Otherwise, it will say that it's an original object itself. So let's check that. So I have my array 22 already. So what I try to do now is that, let me try to create a is equal to, this is my array 22, that I do a copy, that is a. Similarly, I create a b that is equal to my 22 dot view. Okay, so I do this. Now what I try to do here is I'll print this a dot base. I'll also try to print the b dot base. So we'll be able to look at the difference. So it says none. So when you say it's none for the first print, that is a has none. So as you can see here, the base that returns none if the array owns the data, it's its own. Okay, the base is, this means base is an array, means already existing array is actually what is pointed by you. So that's why it's, you don't own the data. So b does not own the data, a actually owns this data. That's what is the meaning of this. All right, let's go further. Next, so we have to identify, so we know how to look at the dimension, what dimension it is, we know that. But if it says 3 dimensions, there are 3 different dimensions, but I don't know what is the shape, right? So how many number of elements are there in each of the dimension, I don't know. So to identify that, what we do here is we try to find out the shape of an array. So to identify that shape of the array, we need to use an attribute that is called as the shape. Okay, so this is how we do that. Let's try to create 23 is equal to, this is np dot array. Let me create a 2-dimensional array. So need to write 2 dimensions inside this, 1 2 3 4. Then the second dimension comes in the picture, 6 7 8. So now I want to find out how many elements are there in each of the dimension, correct? So what I can do here is my my array 23 dot, it's an attribute called shape. So it says 2 comma 4, right? It's obviously, that's because if I print and check this, you see that we have 2 rows 4 columns. Okay, so that's a way how we try to, right, find out the shape of an array. All right, then one more very important aspect of dealing with these n-dimensional array is that sometimes you might collect the data in a specific dimension, in the specific format, like 2 cross 4, but maybe you want to represent it in a different format. Okay, different shape might be expected by you. That is because right, you want to process the data in a different form. So whenever that is my goal, the operation that you will perform here is called as the reshaping. Okay, so the reshaping is what is going to come into picture. Now let's try to get an example, such as say 1D, 1 dimension two dimension. If you want to do that, this is what we will be doing. So my array 24 is equal to np dot array. Let me create a one-dimensional array first. Let me say I have created this array, and I will convert this into a new array, right? So let me try to print this once, so that we'll definitely able to visualize this. So print, or you can even check the shape, that's also fine. 24, so I'm printing that, that's fine. Now my array 25 is equal to my 24 dot reshape, because reshape is a function, right, which actually helps you to make a conversion, right? So this actually, the one dimension was one row 12 columns. What I try to do here is 4 rows 3 columns. Okay, and I print this my array 25. So you see, it got converted into that. Similarly, I can actually I can give an example, 1D, 2, 3D. So I already have 1D array, that is my array 24. I convert my array 25, 25 is already done, 26 should be equal to my array. I have 24, which is one dimension, dot reshape. Now you need to specify all the 3 dimensions. How many pages you want to create, you just have to tell. Let's say, right, I want 2 pages, so 2, right, which means I have 12 elements. I am left out with 6 elements per page. So 6 elements, how can you arrange? You can say 3 rows 2 columns, or 2 rows 3 columns, 1 row 6 columns. Anything you suggest will be happening with this. But let me print to check this. My array. So you see, that's the answer. Right. Then there is one more very important part. This is called as flattening of an array, right? So flattening is very important because I may have any dimension. Okay, multi-dimensional signals are very common, right? Whenever you receive the real-time signals, whenever that happens, it is necessary that specifically when we go to the deep learning techniques or something like that, where you have a neural network taking the inputs, right? Normally we prefer to convert any multi-dimensional signal into one-dimensional signal. So if you have that, it becomes very easy for us to, right? So if you want to convert any dimension into a one-dimensional array, it's very easy. You can simply use a reshape, and you can say that, right, convert that into a 1D keys. So already I have a my array 26, which I know that, right, it's a 3D keys, right? What I can do, my array, this is 26, so let me write 7, that is equal to my array 26 dot reshape, and simply write -1. Then print that array 27. So you see that your array got converted into a one-dimensional case.